Now.
Yeah,
Yes, sir,
yes,
we
sir.
can
Yes,
start it,
yes,
Professor.
Professor. We are ready, Professor.
Yeah.
Good morning to each one of you present here. I am Sabarish, Assistant Professor, Department of Computer Science, Chandra Associate College, Niju, here with presenting the welcome address. It is a moment of extreme pleasure to welcome our guest and speaker, Dr. Deep Chandra, Associate Professor, Faculty of Commerce and Business Management, Amrapali Group of Institutes, Haldwani, Nainital District. I also welcome our beloved principal, Dr. V. Nagajyoti, Dynamic Vice Principal, Dr. N. Sujata, respected head of the departments, faculty members, system admin and public relation officer, participants, and my dear students. I am confident that you will find the new ideas, fresh energy to sustain your efforts at the end of the webinar, Techniques of Data Analysis. I wish you all for a very successful webinar. Now, I hand over the session to our principal, Dr. V. Nagajyoti, to deliver the presidential address.
Good morning to one and all.
Good morning.
Sir, hello.
Hello.
Sir, am I audible, sir?
Yeah.
Okay. Good morning to one and all. Of you for this technical techniques of data analysis webinar.
Yeah.
And this is one of the most important area as far as your research is concerned. Whether you have completed your doctorate or yet to complete your doctorate, this is one of the much needed subject as far as thesis writing is concerned. The basic purpose of bringing such a very big personalities like D. Chandra to discuss about techniques of data analysis is to cultivate a interest on research in the minds of the young teachers of our college. Because most of our teachers, either you are doing your doctorate or you are going to do your doctorate. And there is another important area under the national education policy that we have to publish large number of articles, that too in particular in Scopus and Web of Science. This type of journals, when you are going to publish, it requires no lot of dedication and a lot of hard work. And again, that you should know what are the techniques that to be deployed while writing an article. Similarly, the same things is applicable when you are going to complete your PhD in your thesis. So therefore, we have such a brilliant personality today with us who is going to deliver about techniques of data analysis. And that is one of the most important and a vital area, particularly for article writing or any project preparations or writing your PhD thesis. In all these areas, it is going to help. So let me express my sincere thanks to our management for giving this wonderful opportunity to us and all the facilities to us and all the infrastructural requirements, whatever that we have needed. First of all, let me express all my sincere thanks to all of our management committee members. So I expect all the teachers, those who are watching this webinar, please try to attend the seminar seriously and try to make notes, whatever the sir says. And we can also discuss about these areas once the college reopens. We will discuss about the techniques of data analysis. I mean, we'll have some more hands-on exposure on various statistical packages which are available. So nowadays, there are different statistical packages are available. SPSS is there, and again we have R programming, and we have Python programming. So these are all open sources, and with these open sources also, it is possible for you to, do your all statistical calculations. And similarly, Excel. Last week, we had a program on Excel, and those who are interested, and if you join in Excel sheets, again that also will provide you, to enrich your knowledge in this area. So one need to be an all-rounder, and an all-rounder only will survive in the new competitive era, which is going to come in from June onwards. The National Education Policy 2021 is going to be tough for all of us, and we have to upgrade our knowledge, and we have to incorporate whatever the knowledge that we acquire from these sources and we have to deliver this in a class. So I wish you a happy learning, and thank you so much for giving this wonderful opportunity to me. I hand over this session to Mr. A.P. Babu sir for further proceedings. Thank you so much.
Thank you, sir. Good morning to everyone. I am A.P. Babu, Assistant Professor and Head, Department of BCA and MSc Computer Science. First of all, I thank our management, Principal Sir, Vice Principal Madam, for giving me an opportunity to this occasion. Now, I am happy to introduce our today's chief guest, Dr. Deep Chandra, an Associate Professor from 2017 to till date. He is a retired Vice President from the Nainital Bank Limited, serving 33 years. He is a postgraduate of MSc Statistics, MBA, CA-IIB, also completed doctorate. He also serves as a member of International Indian Statistical Association, member of Indian Association for Research on National Income and Wealth, and teaching strategic management, also business research methods, marketing of services and banking. Now I invite our chief guest to take over the session. Welcome you, sir.
Yeah. Thank you, Mr. Babu, for
Thank you, sir.
introducing me nicely. First of all, at the outset, I would like to thank Mr. Lalit Kumar O. Jain, Secretary, Sri Chandra Prabhu Jain College, Minjore, and Dr. V. Nagajyothi, Principal, Dr. N. Sujata, Vice Principal, and Mr. A.P. Babu, Head Department of BCA and MSc Computer Science, and Mrs. S. Akila, Head Department of BSc Computer Science, for offering me this wonderful opportunity to be amongst the teachers and students of your esteemed college. And I would like to begin this seminar or the webinar on the topic techniques of data analysis by telling you something about the teachers. You know that education means illuminating minds, igniting minds, awakening child to cultural values, creating windows for mirrors, and kindling the flame of knowledge. And not only a teacher explains its subject lucidly, but also enhances his knowledge. Teacher is in fact an engine of educational system. Now I come to the topic. You know that I have been invited on telling you the techniques of data analysis, which is research. What is research? Inquiring or searching again and again, undertaking an inquiry for the second or more times, means to say that we can understand it as repetitive and imitative research. But research is not confined to this much only. It is generation of new knowledge. We are carefully searching for new facts. Research is uncovering or discovering of unknown facts. I hope this is clarifying its role, encompassing the new knowledge, careful search for new facts, and discovering of unknown facts. I would like to request you, whenever there is an issue or you want to say, kindly tell me, so as I could be more explanatory on that issue. In fact, research is an endeavor to know the knowable unknowns. I said knowable unknowns means the factors we are searching for, the unknown factors which are impacting a particular situation, but only and only if these are knowables. What here means to say, to define knowable means for which some research is there, some data is there, or some perception is there, or some insight can be obtained for the knowledgeable persons. Means to say that the subject matter should be knowable, and knowable unknown aspect of reality or the truth of the phenomenal world. You can also define research as a systematic inquiry for finding relevant facts about the subject of investigation. Am I audible? Am I audible?
Yes, sir, it is audible, sir.
Please go ahead.
I'm audible? Yes.
Yes, sir. Yes,
Yes, sir.
sir.
Yes, sir. Please go ahead.
Now, this is what is research philosophy. Research philosophy is beliefs and assumptions, and the research design. What beliefs, what assumptions you are having before the research is commenced, that forms your research philosophy. Basically, philosophies are divided in three parts: ontology, epistemology, and axiology. Before that, we have one paradigm of objectivism and another is subjectivism. What is objectivism? It is viewing single truth or reality. It is the paradigm of ontology. It is realism, what exists. And another one is subjectivism. Subjectivism comes from perceptions, different perceptions. These are multiple realities being looked upon by different perceptions of different people. Suppose there is sea water. Someone will say it is green, someone will say it is greenish, someone will say it is blue, someone will say it is dark blue. So there is some sort of subjectivity that is different by perception, or we are categorizing the things in nominal form. This is what research philosophy is, and these all have bearings on the research. In fact, what is there now? Beliefs and assumptions are at three levels. One is ontological level. Ontology is the branch of philosophy of reality which studies reality, existence, and concept of being, becoming, and becoming reality. It is about nature of reality. What happens? Suppose our physicist, the scientist of physics, categorizes to divide different things. It simply describes the things, describes the reality of things. Just like an example from Mendeleev's table of classification table. Okay, they are periodic table. This can, we can understand that it is only descriptive part which it is touching. Ontology, they are dividing things existing in the social world and assumptions about the form and nature of social reality. It is in a way positivism. Whatever is existing, we are defining that as reality. This is what research philosophy is. And research philosophy
Sir, yes, sir. Tell me, sir.
Sir, left நினைக்கிறேன் sir.
என்னது அப்படியே
Sir, disconnect ஆயிருக்கு sir. Let him join. Sir.
சரி 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 உங்ககிட்ட பிபிடி போட்டுருங்க போட்டு அவர் சொல்லுங்க.
Let him join, sir. I'll share the PPT, sir.
சார் பாபு சார் அவர் நம்பர் கால் பண்ணுங்க. பாபு சார் ஓகே சார். தேங்க்யூ சார். தேங்க்யூ சார். ப்ரொஃபசர் ப்ளீஸ் ப்ரொஃபசர்.
Sir, PPT ready. Let him join and continue, sir. Sir, any update on guest, sir?
Hello. Am I audible?
Audible, sir. Audible, sir.
Sir.
Audible. Now you please tell me since when I was not audible.
Sir, audible, sir. You continue, sir.
No. Can you please tell me at which slide I left you?
Second.
Second slide means I was just, I'm coming to that slide.
Sir,
This slide was,
let me share your slide, sir. You just open it and tell me next, sir. I'll share the PPT,
okay.
sir, full screen.
Is whether it was discussed with you research paradigm. Hello.
Yes, sir. Yes, sir.
Yes, sir.
It was okay.
Yes, sir.
The next is this. This was the next slide which I was sharing. This is research onion. Am I audible?
Yes, sir. Yes, sir.
So this was Saunders research onion model. As you all know that the onion has so many different layers. Outermost layer is the positivist philosophy, critical realism, interpretivism, and postmodernism. What I was telling to you is positivist philosophy or ontological philosophy takes its roots from the truth or reality. You have a particular idea in your mind, particular theory in your mind, and then you obtain the data and try to test the hypothesis or try to confirm it or to negate it. Then is critical realism. Critical realism and interpretivism to this extent are confirming towards the second approach of abductivism, which is in the next layer. In fact, the next layer is of the approach to theory development. It is deductive. Deductive is coming from positivist theory. It has a theory in its mind and then it is deducing the data, and data is confirming or not to confirm that particular theory. Then is the abductivism. Abductivism means it is trying to either to confirm or not to confirm, and again collecting the data, and it is trying to have some connectivity with that theory. It means it is another way superior to deductive theory. Then comes the inductive theory. Inductive theory is in fact postmodernist. It is not coming itself with a particular notion, particular string. It is not attached with. It is trying to obtain the data and then trying to evolve some new theory which can be a new invention also. I think I have explained these two layers together. Then there are methods. Method is mono method quantitative. It means only quantitative methods you are using. Quantitative methods are survey methods or experiment methods. Then is mono method qualitative. Mono method qualitative are sentiment analysis, content analysis. These are qualitative methods. These are expert interviews. They are expert panel interviews. They are group discussions. You don't have numerical data in this, then is multi-method quantitative. You are on one side you are doing some survey, or another side you are doing some experiments. You have more than one quantitative method applied in multi-method quantitative. Then is multi-method qualitative. Multi-method qualitative means you are sometimes doing some phenomenological study, sometimes you are doing some study within the tribes of the people. You are going to stay with them, you are going that for that study, and sometimes you are doing some content analysis or the views of experts on that particular topic. Then is mixed method simple and mixed method complex. These are the methods. Then there are, these are the techniques and procedures. What are these? These are experiments, surveys. Experiment and surveys are quantitative methods. Then is archival research, case study, ethnography, action research, grounded theory, and narrative inquiry. These all are, except survey and experiment. All these all these five: action research, archival research, case study, ethnological study, narrative inquiry, and grounded theory, are qualitative methods. Then comes the time horizon of the research. What is it? It is cross-sectional or longitudinal. Cross-section means just one slice of the pie, means you are not taking time into the consideration. You are collecting all the data at one particular point of time. Okay? Meaning thereby, longitudinal data is a data collected on same objects over a period of time. Here, time itself becomes a variant. Okay? Sometimes we are confused about the time variance, and suppose we are trying to investigate the performance of 10 students, and we are evaluating them right from first standard to 10th standard. Their performances may be due to their labor and the time put in their studies, or it can be with the maturity of their mind. With the passage of time, they can become more intelligent. If only the time frame or the time is considered, then it is called a time series analysis. It will be longitudinal in nature. Is it clear? Any issue? Hello? Am I audible?
Absolutely, you are audible. Please continue.
Okay. Last layer, which is the innermost layer of this onion, is data collection and data analysis. In fact, this was the point where I wanted to draw you, because this data collection and data analysis, which I have to dwell upon, has bearings of all these previous layers. All these layers decide upon the fate of data analysis. Okay? Now, there are only two things of this are to be cleared again. That is approach to theory development. This is deduction, induction, and abduction. I hope you all have studied this. Deduction and induction is very much clear to everyone. But abduction seems to be a new term here. What is this abduction? Abduction is deduction means we are given a theory and we are collecting a data and we are fitting a model, and then we are trying to predict using that model of our parameters or anything. Whatever is our dependent variable, we are trying to predict its value depending upon the values of independent variables. Then next is generate a theory you use. We are trying to generate a new theory. It will come in under the head of invention, innovation. This is the new thing we are generating. But in abduction, neither you are generating a new thing nor you are deducing a thing. What you are doing, you have kept the ideology or the idea or the sensitivization of a particular thought in your mind. At the back of your mind, you think that it might be related to that particular theory. But at the time of data collection, you are not keeping that in your frame of mind. You are openly collecting the data, and after collecting the data, you are trying to fit some theory in it. You are trying to find some causal relationship between these two. The theory which you have in your mind and the data, whether it is conforming to that or not conforming to that, is the issue here. I hope this is clear. There are three instances given here. In deduction, all the beans from this bag are white. These beans are from this bag. Result is the beans are white. Induction, beans are from this bag. These beans are white. Rule will be all the beans from this bag are white. But in abduction, all the beans from this bag are white. These beans are white. These beans are from this bag. Okay? This is, if you just relate it, is trying to go back. Okay? Like in the conditional probability, what we do, we just try to find out the name of the urn from this ball was drawn. Earlier we were calculating the probability of drawing the ball from the urn. Now we have the result and we have to go back. This is that sort of thing. Statistically, I am saying. Now I am beginning with the data analysis part. I told you the data analysis will be dependent on what are the variables of the study, what are the scales of measurement of the study, and what is the sampling frame. What is the sampling frame? And now I will be clarifying this in detail to you. Okay. What is here? What is a variable which changes is called variable. They might vary between people. IQ, behavior, location, employment, gender, income, anything can be a variable. Just given an example of mood also. Mood is a variable because it varies. Now, what is an independent variable? A variable that becomes, that precedes the result, that precedes result means that is a cause of the result. Are you with me? A variable that we think is an effect is dependent variable. The cause is independent variable and the effect is dependent variable. Suppose I take an example of employee satisfaction. Employee satisfaction is a result of pay scale, service conditions, position offered. So the employee satisfaction is the result here. So this is a dependent variable. And the pay scales, the experience, and all other things are independent variables. Okay? Next is, in experimental methods, the cause is actually manipulated by the experimenter. What is there? Suppose in agricultural experiment, you are trying to find out the yield of the crops on the basis of irrigation patterns or the usage of fertilizers or the usage of different types of seeds. Then this seed, this fertilizer, and this irrigation method can be changed. These can be manipulated. So these variables are independent variables. The variables which are manipulated are independent variables. But what is there? Next slide says, in cross-sectional research, we don't manipulate any variable. What is there? In cross-sectional studies, if we are studying the crop estimates, the yield of the crop for a particular point of time, then here no variation is there because it is at a particular point of time. Okay, so cross-sectional studies are descriptive in nature. They are not telling you the effect of the change in the levels of different independent variables. Okay, and we are not able to make any causal statement about the relationship between variables. Then comes another nomenclature, is that we use dependent variables, or we give dependent variables a different name, outcome variable, because these are outcomes, these are the results, these are the effects. Whereas the predictor variables are independent variables, which are going to help us predicting something. Okay, predictor variable is variable thought to predict an outcome variable. This is basically another term for independent variable. Next is outcome variable, a variable thought to change as a function of changes in predictor variable. This is your dependent variable. Here comes the next slide, which says the relationship between what is being measured and the numbers that represent what is being measured is known as the level of measurement. Level of measurement is the relationship between the item and the measurement or the observation for that. Suppose I ask you, to what extent do you agree with the corona vaccination program by government? To what extent do you agree that corona vaccination program is working well? And I ask you to give your opinion from 1 on the scale of 1 to 7. So you will be choosing either 1, 2, 3, 4, 5, 6, 7. If you are perfectly agreeing that it is working well, you will say it is 7. I have taken this Likert scale for 7 measurement values because it is said in research paradigm that it should be at least on 7 scale so that it could give us better measures and normality also. Okay, so this is level of measurement is the value which is being observed. Next is variables can be of two types. Here it says. Next, it will tell you that it is of 4 types. But these are broad categorizations. One categorization is categorical or continuous. Categorical or continuous. Another term will be metric and non-metric. Categorical variable is made of categories. Okay? Humans, domestic cats, wild animals. There can be categories. One category, football team of Manchester United, football team of some other country, different football teams of India, Mohan Bagan or East Bengal or Mafatlal. There can be go odd and post. So there can be different teams. These all are categories. A categorical variable makes distinct entity. In its simplest form, just two distinct type of things. If there are only two categories like gender, male or female, it is called binary variable. Different categories. Categories alive or dead, pregnant or not, okay, intelligent, not intelligent, good borrower, bad borrower, good insuree, bad insuree. Okay, so these are how this categorical variable operates. Next is when two things are equivalent to some sense are given the same name. What is there? In fact, in a particular category, the observations will be conforming to a particular norm or particular discipline will decide whether this thing is categorized in this category or not. Suppose someone follows Christianity, another fellow is Jewish or Hindu for that matter, then there can be these two categories, and since these are given more than two possibilities, then this variable will be called nominal variable. Nominal variable in its crudest form of 2 is called binary variable. When it is more than 2, it is called nominal variable. Now, what are the implications of this nominal variable for the use of data analysis? It is very important. because what is there? A nominal data is there. So we have collected the information about the respondents, whether they are women or men. What can be their treatments? There can be numbers only. You have got 10 numbers of women, 15 number of men, or 15 number of women, or 10 number of men. If 25 respondents are there, then these numbers can give you simply the percentages. They can give you simply the counting numbers. They can be tabulated, simple tabulations, frequency tables can be made, and please note that cross tabs or chi-square test can be made applicable to them. Suppose you have gathered the data, how many were the corona vaccinated and how many died. How many were not vaccinated by corona and how many are alive. These, suppose I talk of this 4 quadrant data, then you can have some relationship between the death caused by corona and the corona vaccinations effectiveness. You can judge through the cross tabulations or through the chi-square test here. Okay, chi-square test will be applicable not only to 2 classes but to different classes also. It can be operated. Okay, and next category is ordinal data. Now what is ordinal data? In ordinal data also you have different categories, but you have, suppose you make all the students of your class stand in decreasing heights order. Okay, then you may observe that the top height student may be of 5 feet 4 inches, and the next one can be of 5 feet 1 inch, and the next can be 4 feet 11 inch. So the difference between the heights of consecutive students will not be similar. It may be similar, it may not be similar. But there is some ordering can be done. Ordering means, but whereas in that first case, nominal data, you cannot say that these are different on some ground, male, female. You cannot say that they are different. But here in ordinal data, you can for sure say due to some particular absence or the presence of a particular phenomenon. If you are talking of height, then height is the criterion which is discriminating between all those observed variables. Okay, so what is there? There you cannot say that the male are superior to female or female are superior to. But here, if you have classified or if you have divided the data on the basis of educational qualifications. Suppose I say there are 5 classifications: matriculate or high school, 10 plus 2, graduates, postgraduates, and then doctorates. 5 type of data, then it is very clear that the person who has a doctorate degree with him, who holds a doctorate degree with him, has already qualified all those examinations: post-graduation, graduation, 10 plus 2, and 10th. So it is there, some sort of ordering is there. Okay? Some sort of ordering is there. That is what telling you about the data that but the difference between these two categories, there are 5 categories, but the difference will not be the same. Okay? Next we come to the interval data. In interval data, in ordinal data, what I was telling you, that you can always go for computing median, computing quartiles, computing rank correlation coefficient. Okay? Whereas in nominal data, we were simply doing counting of numbers, cross tabulations, simple tabulations, frequency tables, and chi-square tests. Here in ordinal data, we are able to perform the median, quartiles, and rank correlation coefficient we can be computing. What is there in interval data? In interval data, different categories are there, and the difference between those categories is the same. As I told you that the highest student had there the height of 5 feet 3 inches, then it was 4'11", then it was 4'6", meaning thereby that in different categories there will be no similar difference, but as regards to n, this interval data, it is very much similar. It is very much similar. And one more important thing about interval data is that there is no absolute zero. Here arbitrary zero is there. One category we make, you might have heard zero size. The zero size shoe for the newly born babies. Zero means absence. It does not mean that there is no shoe. It is shoe with the minimal size, which is called zero size. Even for the actresses in Bollywood or Tollywood or whatever it is, we also have zero figure. Zero figure doesn't mean that she is invisible. She is visible but has zero figure. Means arbitrary zero. It is not an absolute zero which has been made by or defined by the mathematicians. More examples are given for this, as you say that the temperature 0 degree centigrade doesn't mean that there is no temperature. There is a temperature, means it is an arbitrary zero. This is an example for this. The data is interval. Equal intervals on the scales are there. Suppose students are asked to rate their lecturers on several dimensions. Each dimension is evaluated on 5-point scale. In this scale, suppose we are noticing the helpfulness and clarity of the subject, then There the difference between the rating of 1 and 2 is the same as the difference between rating of 3 and 4 or 4 and 5. And now comes ratio variable. What is ratio variable? We have told you that mostly the variables which are not categorical or interval are automatically the ratio variables. What is ratio variable? Suppose I ask you what is your age. You will say that my age is 37 years, 9 months, 2 days. What does it mean? It means that it is not an exact figure. Exact figures are called discrete figures. But those figures which are represented in decimals are continuous data or the ratio variable. Decimal data means it is divided by 10. It means ratio is possible, division is possible. Wherever division is possible, it is ratio data. Okay? Wherever division is possible, it is ratio data. It goes one step further than interval data. Okay? Here we can have this scale must have a true and meaningful zero. Okay, we can say that this is, here an example is being given, the time to respond to something is a good example. When we measure a reaction time, not only it is true, is it true that say difference between 300 and 350 minutes means the difference of 50 minutes is the same as difference between 210 and 260 minutes. But it is also true that the distance among the scales are divisible. We can say that reaction time of 200 minutes is twice as long a reaction time of 100 minutes and twice as short of the reaction time of 400 minutes. I hope it makes it clear. Continuous variables. Now, what I was telling you or explaining, continuous variable can be continuous but also discrete. This is quite a tricky distinction. What I told you that if I ask you that what is your age, if you tell me that it is exactly 37 years, it is discrete. If it is not being mentioned without any decimal, okay, discrete variable can take only whole numbers on the scale. Suppose in our last example where we were rating lectures, the range of the scale is 1 to 5. We can give values 1, 2, 3 or 4 or 5. We cannot enter a value of 4.32. Okay? A continuous variable would be something like age, which can be measured at infinite level of precision. Okay? He has given an example of 34 years, 7 months, 21 days, 10 hours, 55 minutes, 10 seconds, 100 milliseconds, 63 microseconds, and 1 nanosecond. So this is perfect example of continuous or the ratio data. It is again an explanation of, this is very important because these 4 type of data, nominal, ordinal, interval and ratio, decide what type of technique you will be employing. Okay. Categorical data is nominal variable and ordinal variable, and continuous data is interval variable and ratio variable. Next slide is, to test hypothesis we need to measure variables. Before this testing of hypothesis, I would like to embark upon what is hypothesis itself. Hypothesis means any conjecture or any statement about the parameters of the population. Now you know what people say, that there can't be any definition when there is any other word which has to be explained further. I wanted to know the definition of hypothesis, and I now used the word parameter. Parameter again needs its explanation. Parameter is any figure representative of the population. Suppose I say a population of lecturers, and I assume that 45,000 is the average salary of lecturers. Then this 45,000 representing the salary, average salary of all the teachers in Tamil Nadu, is a parameter for this population of lecturers in Tamil Nadu. If I tell you any statement about the average salary, then it becomes a hypothesis for this purpose. And hypothesis can be also about the average educational level of teachers. It can be any sort of any characteristic of the population about which you can frame a hypothesis. Now, what is testing of hypothesis called? Testing of hypothesis means verifying it through the different observations, data emanating from different respondents. You are trying to verify it from that. Okay? To test hypothesis, we need to measure variables. Obviously, it is very important that we measure these variables accurately. Ideally, we want our measure to be calibrated such that value have the same meaning over time and across situations. Weight is one example. We would expect to weigh the same amount regardless of who weighs up or where we take the measurement. Okay? What it is trying to say is that your weighing machine should not have any error, nor the person who is weighing should not cause an error to that. This is why they say that the measurement should be errorless. But all the errors, all the measurements are full of errors. What I can say, that there is no measurement, there is no observation which does not contain any error. It is rather impossible. But there should not be deliberation on our part. One type of error it has given here, a discrepancy between the numbers we use to represent we are measuring and the actual value of thing we are measuring is known as measurement error. A beautiful example has been quoted in this preparation of slide. I have used Andy Field's book. Almost all the examples are there. I am quoting this for your knowledge. It says that you weigh 83 kg. One day you step on the bathroom scales and it says 80 kg. You know that your actual weight is 83, but your weighing scale says that you are 80 kg. You are not 83. So you should know whether your machine giving output has gone out of order or it is not giving the correct figure. So it is measurement error. Another beautiful example is that if someone asks you whether you had stolen from a shop, what would you reply? These are the questions. Suppose someone asked you, have you stopped beating your wife? You are in a dilemma. You are in a fix whether to say yes or to say no. Because if you say yes, means you have been indulging in beating your wife so far. And if you say that you have not stopped, means you are still continuing the practice. These are called leading questions. These questions should be avoided because they do not measure what they should have measured. Now this is validity and reliability. Validity means which is whether an instrument actually measures what it sets out to measure. Suppose you want to measure the employee performance. Okay? Employee performance will be ascertained through the outputs, what he is producing. But you are asking some question which is irrelevant to the production of that output, that then it is not measuring it properly. However, relationship you may try to establish, but the question should be okay. Next is reliability. Reliability in general means that whatever you wish to measure, if you repeat it for so many times, then their measurement should be reasonably similar. Okay? It should be reasonably similar. Now this is content validity. Questionnaires, we can assess the degree to which individual items represent the construct being measured. Validity is a necessary but not sufficient conditions of a measure, because validity is generally taken from the experts on the area. If you have taken some questionnaire for your research from a renowned expert who has been on ABDC Journal or Web of Science Journal, on a good journal, A plus star journal, then it is a valid questionnaire, valid scale you have chosen. Next is scientific statements. This is about what types of hypotheses are there. One is H0, H0 is called null hypothesis. It is null hypothesis is the hypothesis which is normally tested for possible rejection, except for the very few hypotheses where we are searching for the normality of the distribution. Then this is when it is accepted, we are happy. Here happy on the sense that we say that here squeezes and kurtosis are out of order. Then it is not done. So we are not rejecting it, but we are accepting it. Next is alternative hypothesis. Alternative hypothesis, in fact, is the statement which is in our mind initially, which we want to prove. In fact, what we are trying to do is we are trying to reject our null hypothesis. In fact, in statistics, we say that the data is not conclusive about, or data does not prove evidences to allow us to fail to accept the hypothesis, or the sufficient evidences are not there to accept the hypothesis. That is why we are rejecting the hypothesis. Hypothesis acceptance or rejection has two criterions. One criterion is that the value of the statistic is compared with the value of calculated value of statistic is compared with the value of statistic as given in the table. Another is the p-value concept, which is being given in so many statistical softwares. You can take SPSS, you can take eViews, you can take this AMOS, you can take PLS3. There are so many softwares where you are getting these p-values. Many of the studies, now this is another distinction. What is there? All the observations which we have collected and all the statistical basis, entire statistics revolves around central limit theorem. Central limit theorem says that the as many as samples you draw from the population, their mean, they are forming a part of the normal population. Means as many as samples, as large as samples you take, all the samples put together, if they are all the samples put together form a part of a normal population. That is why these are based on normal distribution. The hypothesis of observations being normal is primordial for any type of parametric test. And The non-parametric tests, which are also called distribution-free tests. What are those? Which do not hypothesize about the population parameters or the shape of the shape of the distribution. They never assume that they are normal distribution. Okay. So first of all, what we have to do is, whenever we have collected the data from our respondents, we say that the data is, we check whether the data is normal or not. Now comes the assumptions of parametric tests. Normally distributed data. This is a tricky and misunderstood assumption because it means different things to different contexts. Rationale behind hypothesis testing is that normally distributed sampling distributions. In others, so if this assumption is not met, then the logic behind hypothesis testing is flawed. Second important thing is homogeneity of variances. This assumption means the variance should be the same throughout the data in design in which you test several group of participants. As we have already discussed, that interval data and ratio data are suitable for testing of hypothesis. In many statistical tests, we assume that the sampling distribution is normally distributed. Central limit theorem, which I told you earlier, that if sample data are approximately normal, then the sampling distribution will also be. That is why we are always trying to obtain the normality of samples. If the samples are normal, then it means that all the tests can be applied. Suppose we have got 10 samples and all samples are normal, means the aggregate population is also normal. So whatever we can say for sure about the samples can be generalized to the entire population. This is the crux of this central limit theorem. Next we come to check the distribution of scores is approximately normal. To check the normality, what we do is we go for skewness and kurtosis testing. Skewness, as you know, is giving you the tilt on left side or tilt on the right side. And kurtosis is telling you the, I must say, the peak is how much flat or how much it is conical. It is the peakedness of the data. And I'm just skipping this. Coming to the next. Descriptive statistics and histograms are a good way of getting an instant picture of distribution of data. Again, this is a way histograms can tell you how the data is looking like. Okay, you know that the normal distribution has unique mode, median mode. They are not bimodal. There is one mode only. For example, the bimodal distribution of SPSS exam scores instantly indicates a trend that students are typically either very good at statistics or struggle with it. Intuitively, This finding fits the nature of the subject very easy once everything falls into place, but before the enlightenment occurs, it seems hopelessly difficult. So, one way is the histogram and graphical representation. Another way is Kolmogorov-Smirnov test and Shapiro-Wilk test. These two tests are there for verifying the data normality. Then the homogeneity of variance. Homogeneity of variance can be tested through Levin's test. Levin's tests the null hypothesis that the variances in different groups are equal. Okay, and if it is non-significant, then the variances are roughly equal and the assumption is steady. Okay, now this is where and how, this is the crux of all of the techniques of testing the data. This is what univariate techniques. Univariate techniques means for one data set. Bivariate means for two data. If you are interested to study only one characteristic of a population, then it is a univariate study. If you are trying to study in relationship, either relationship or the difference in two characteristics of the study, then it is a bivariate study. In univariate techniques, there are two types of things. One is metric data and another is non-metric. And in the case of non-numeric, means categorize non-metric data, it is one sample test. If it is one sample and the variance of the population is given, then you apply Z test. If you don't have the population variance given, then you base your test on the sample variance, then it is T test. If it is two or more samples, then if they are paired samples, then it is paired T test, otherwise it is independent test. There are two groups, then it is two group test. If there are more than two groups, then it is one way ANOVA. Next is, if it is one sample, non-numeric data. Non-numeric data means it is not metric but it is categorical data. Frequencies are given, then it is run test, it is non-parametric test, it is chi-square test, and if it is two or more samples, then it is independent test, chi-square, Mann-Whitney, median, Kolmogorov, Smirnov, KW, ANOVA, and Kruskal-Wallis ANOVA it is. Okay? Sign test, Wilcoxon test, McNamara test, and chi-square test. These are the different type of tests which are important in this. Next is, there are two type of major techniques. Data analysis. One is if the number of variables, number of dependent variables, one or more, If there is no dependent variable, all the variables are of similar nature. There is no one dependent, there is no one independent. Can it be that? Yes, it can be there at the preliminary stages of analysis or preliminary stages of research, when we have not been able to find which is the dependent variable, which is the independent variable, then these interdependence techniques are used there. These are factor analysis, cluster analysis, multi-dimensional scaling, and correspondence analysis. If number of dependent variable is one or more, if number of dependent variable is there, then these are dependence techniques. Now comes how dependent variable is measured. If it is measured on metric scale means interval or ratio, then we can use correlation analysis, bivariate and multiple regression, ANOVA, and multivariate analysis of variance, that is MANOVA, or conjoint analysis, or canonical correlations, or canonical analysis. If dependent variable is metric, if dependent variable is non-metric, if it is nominal, then discriminant analysis, conjoint analysis, or logistic regression. If dependent variable is ordinal, then Spearman's correlation, median, quantile, these can be used. Now the most important phase, another important phase is, I told you that the data analysis depends upon which type of data you are collecting from the respondents. I just now told you that if the data you are collecting from the respondent is metric or non-metric, different treatments were suggested in the previous slide. Now it is there that what type of sampling techniques you have used. There are different type of sampling techniques. What is there? What is the difference there in our normal perception and the statistical perception? What we say random, we understand that random means who comes suddenly, who is coming randomly without any planning, which comes, whomsoever we meet, whatever comes, just like we are waiting outside a mall for knowing the customer perception about the different commodities sold by the mall, and we are collecting the data and we say it is random. I would like to clarify here that it is not random sampling. Random sampling is that sampling which says that each and every unit of the population must have some probability of being selected in the sample. If all the units in the sample have some probability, whether equal or not, that is another thing, because that is sampling with varying probabilities. most general case of probability sampling is simple random sampling, where it is similar. What we do is simple random sampling means, in essence, is listing of all the population members first. List, then go for the random number tables. Two case tables are there. Tippets tables are there. Consult them. These tables are designed in such a manner that you can start from any point. These are giving the random number. Suppose you have got 500 population and you have to choose a sample of 10. What you will do? You will go for 3-digit random number table. 3-digit random number table will be having 100 to 999 numbers. But your sample is 500. It will do because it will be having from 000 to 999. So what you do, you start from any point. Am I audible? Am I audible?
Yes, sir.
Yes,
Please
sir.
continue,
Yes,
sir.
sir. Yes, sir. Audible, sir.
So what you do is you take any point and note it. Suppose it is 230. So 230th observation is selected as first unit in the sample. And you are now starting from 230. Suppose the next number is 456. Then you select it also. Suppose next number is 874 and your population is 500. Then you leave this 874 and come to the next. If it is within 500, take it. And suppose next two are out of more than 500, leave it. This way you will take 10 numbers, 10 respondents. Then you collect data from that. This is the probability sample. I think my example must have made you the random sampling clear. I have come across so many of my friends in the fraternity who are not clear about this. Non-probability sampling design is purposive sampling and convenient sampling, and there are many type of judgmental sampling, snowball sampling, quota sampling. These all are non-probability samplings. This is the sample size calculation, and you know that for the ease I tell you, normally 385 is completing the norm as far it is there. And now very important thing is setting up of a suitable significance level. It is very, very important. What is significance level? Significance level tells us that whatever I am going to profess will be certain to occur only in 95% of the cases if my significance level is 5%. Meaning that whatever statement I am making will be true only in 95% of the cases. In 5% cases, my prediction or my statement can go haywire. It may not prove to be true in 5% in cases. So it is a pinch of salt that you should take this advice with a pinch of salt. That in 5% cases it will be not proving to be correct. Then is determination of test statistic. T z chi-square f. F is for comparing the variances. T is for comparing the means. Z is for comparing the means. Chi-square is for contingency tables. Cross tabs, it is for knowing the association between two variables. Computing the value of test statistic, it is very clear that out of when you have collected the respondents, collected the observations, then we are computing the test statistic, and then on the basis of the value of test statistic we are utilizing it. If the population standard deviation sigma is known, Z statistics can be used. If it is not known, then the T distribution will be used. Likewise, if the population size is greater than 30, we can use Z. If it is less than 30, we can use T. Now, I had already discussed dependence methods and interdependence methods. These are very important as a part of this data analysis. I will be briefly touching over all those. Suppose your questionnaire has 35 or 36 questions. Now all these questions are different items. These are not your variables. What is there? If you are interested in knowing how many factors they can compose of, then there is one important application in. That important application is in SPSS, which is called factor analysis. It is a dependence technique. And now what is the difference between interdependence technique and these techniques? You know that the dependence methods are cause and effect methods, which are giving you a relationship, whereas interdependence methods are not giving you any relationship. They are used to understand the structural makeup or patterns underlying in a data set. No dependent variable, no causal relationship, only grouping variable in a meaningful manner or giving a meaning names. What I mean to say is, in dependence methods, we are utilizing the dependent variable and independent variable technique. Okay? There we are predicting the value of dependent variables on the basis of independent variables manipulations. First one is multiple linear regression. One dependent variable and so many independent variables. Suppose we are interested in knowing the crop yield on the basis of rainfall, temperature, amount of sunlight. These all are independent variables. These independent variables are contributing to variance in the crop growth. Second one is multiple logistic regression. If dependent variable is binary, borrowers, good borrowers, bad borrowers, customers who claim insurance, mostly customers who do not claim insurance. You know that the insurance companies and the credit card companies and the banks even are using this multiple logistic regression technique. Then is multiple analysis of variance, where there are two or more DVs and two or more IDVs. But IDVs are categorical. Okay, this is maneuver. Then another dependence technique is discriminant analysis. Discriminant analysis means IVs are metric and normally distributed. Then what we are doing, we are reaching or arriving at a discriminant functions value, and if the next person who joins a company or comes to a company for being registered as a customer, if it has its discriminant value on the basis of that discriminant function, more than that, it is likely to be rejected or it is to be accepted. So this is giving you a function which can give you whether to accept a customer or not to accept a customer. And last one dependence technique is conjoint analysis. Conjoint analysis is a type of trade-off analysis. It allows for evaluation of subjects. It tells you both composite and dependence technique. Preference for combination of attributes at different levels are summed up and develop attribute at each level. Models can be built that identify the ideal levels and combination of attributes for products and services. And next is the interdependence method. Interdependent methods, I told you, first is factor analysis. Factor analysis is an interdependence technique which attempts to reduce the number of variables. The example which I was giving you, that if you have 36 or 35 questions in your questionnaire, those all questions except for demographic variables, those all questions can be grouped or their dimensions can be reduced on the basis of proximity of the answers given by the respondents. Okay, that correlation between all those questions will group them together to form a factor. In fact, what is there in this technique? Without losing any information, you are reducing the dimension of, and the dimension which comes finally becomes a factor or construct what you call in your final analysis. And you know that this interdependence techniques which are telling you something about the structure of the data. They are telling you something about the shape of the data. They are not giving you any, I must say, because you have not decided what is the dependent variable, what is the independent variable. So there is no question of assessing impact. They all are being treated as independent factors. So to decide the factors, to decide the variables, we first do factor analysis. Next is cluster analysis. Cluster analysis is used to group similar items within a data set into clusters. I told you that factors will be then put to the rigorous. In fact, what is there? First, it is exploratory factor analysis. Then it is confirmatory factor analysis, where we regress the dependent variable on the independent variables. And then we have a predictive model. In cluster analysis, similar items are grouped into clusters, just like customer segmentation or branch segmentation. It is often carried out in early stages to understand the data distribution and find the pattern. Interdependence techniques are not examining the relationship between the variables. They are simply giving us some information about the form of the data. Then is correspondence analysis. Correspondence analysis is used for many attributes and many companies. When the number of companies is large, number of attributes are large, it is trying to assess the effectiveness of
Saravana, and check with the guest. He's not in the studio now.
I will check, sir. I will check.
Hello? Hello?
Sir, guest is
Hello.
not in studio, sir.
Okay.
Sir, yes, sir. Welcome back, sir,
Yeah.
for presentations.
Is my screen visible to you, sir?
Sir, your presentation is not visible. Only your screen
Not
is visible.
okay. Is it visible now?
Sir, yes, sir.
Yes, sir. Yes.
It is visible. Okay.
Visible, but please open the PPT, sir. Yes, sir. Fine.
It is open now.
Yes,
Yes,
sir.
sir.
Yes, sir. Please, sir. Proceed.
So please tell me since when I was not with you. Can you please tell me? I was telling you canonical correlations. You are with
Sir,
me or
now you
not?
are in structural equation modeling.
And at that particular point of time when I left inadvertently the studio where I was, can you tell me?
Saravanan, sir, can you tell?
Can anyone tell me where I was when I left the studio?
Sir, you are on the. Can you go to 20th slide, sir?
20th? No. I was told that for 2 minutes I was not there. Hello? Hello? Hello?
Sir, tell me, sir.
Okay.
Yeah, we are,
Okay,
You
I
are
am.
audible, sir. Please.
please go ahead, sir.
Yeah.
Please go ahead.
I'm just telling you that structural equation modeling is a software which is based on partial
Yeah.
least squares, and it is very good software which along with the
Yeah.
diagrammatic representation it gives you the correlation and the predictions for the dependent variables on the basis of independent variables. And this becomes the last slide. Each of the multivariate techniques described are a specific type of research question for which it is best suited. Each technique also has strengths and weaknesses, and current statistical packages make it increasingly easy to run a procedure, but the results can be disastrously misinterpreted without adequate care. So, what I mean to say is, analysis is a very difficult phase where you have to be alert every time, and whenever you have drawn some result, please discuss it with other friends. But what we are doing, well, since start of our PhD thesis, we are not discussing with our friends, not to talk of the experts. We are shy of disclosing our objectives to our friends. That is why sometimes we are always hiding our thesis from others. But thesis are nowadays put on net itself. You can also view my PhD thesis, which I have done in Uttarakhand Open University. From Uttarakhand Open University, Department of Management Studies, you can see my thesis in management, and my title is an assessment of credit risk management and financial performance of banks, a case of Nainital Bank Limited. That's all from my side, and I hope that you might have liked the presentation. Of course, it was more or less a theoretical representation. It was not a practical representation. But I hope that so many things or so many apprehensions might have been dispelled, might have been clarified by me. And thank you very much. And if anyone has any question, then please tell me.
Thank you, sir. That was a wonderful section. Sir, participants, any queries? Sir, Balaji, sir?
So as of no questions in the comment box. If anything, I'll just highlight it.
Okay, okay. So I should say thank you to you. Thank you for giving me a chance to be with you, and hope to be with you some other time also.
Sir, shall I go for vote of
Thank
thanks?
you very much, Professor. Thank you very much.
Sir, shall I go for vote of thanks?
Vote of thanks. Please go for vote of thanks, sir.
Thank you, sir.
Yes, sir. Yes, sir.
Good
Please
afternoon.
go for vote of thanks.
Okay, sir. Okay. Good afternoon to all. This is Saravanan, Assistant Professor, Department of BCA, to deliver the vote of thanks. It gives me an immense pleasure to propose the vote of thanks on this memorable occasion. Our sincere thanks to the resource person, Dr. Deep Chandra, Associate Professor, Faculty of Commerce and Business Management, Amrapali Group of Institutions, Uttarakhand, for gracing today's webinar. Thank you, sir, for your interesting and valuable information. Our hearty thanks to our Secretary, Sir Lalit Kumar Ojain, Principal, Sir V. Nagajodi, and Vice Principal, Ma'am N. Sujasa, and HODs, Babu, Sir, and Akila, Ma'am, for their valuable contribution, guidance, and encouragement in all our efforts. My heartful thanks to HODs of various departments, faculty members, and students. We express our thanks to Balaji, Sir, for his continuous support. Once again, I thank you all for your attention. Thank you.
Thank you, sir. Thank you.
Thank you very much, Professor.
Thank you, sir. Thank you.
Professor, thank you. Thank you very much. Thank you. Thank you.